Okie dokie. Hey.
Howdy-rooney. Yeah.
How's it going?
I'm Graham.
Good. I'm Ashkahn.
And today's question is, are there any concerns I should have about using ozone?
You, Graham?
Well, no, there's the person writing the question. Unless their name was Graham, too.
It could be.
We don't read names over the airwaves, so I'll wink twice if Graham was their name.
Okay. Oh, it was Graham.
Wait,
what? Was I not
you know
supposed
what a
to say
wink
that? Okay. Ozone.
Yeah. So it's one of the methods that manufacturers use for disinfecting float tank water.
And it's good at killing things.
And actually cleaning walls, too, potentially, which is not true of things that go into the water normally.
Yeah, so ozone is it's a gaseous, it's like what happens is you have like some device in your float room, near the filtration system called an ozonator, and it's this box that's usually mounted on the wall, and that's taking oxygen, O2, and doing some crazy stuff to it and turning it into O3.
We're not engineers.
Or chemists or a lot of, and then that gas, that ozone gas, goes out of a tube, and that tube connects typically somewhere in your filtration system. For float tanks, it's often connecting just to kind of a piece of piping, or what's sometimes called an injector manifold, or some sort of way of getting it in. In bigger facilities like pools and stuff, where you may see this, sometimes they have contact chambers where the ozone's ejected into a big thing, and they let it sit in there for a period of time before moving it to the rest of the system. But for float tanks, typically just kind of a tube straight into another tube.
The old tube-in-tube solution, yeah.
We'll draw you a diagram in the show notes. And and the diagram will use at least 5 different colors.
So it's an interesting one because I think it has some concerns that other forms of disinfection don't for float tanks. And specifically just the nature of ozone being a gas can lead to potential problems.
Yeah, so a lot of it is, the air quality stuff comes up with both chlorine and bromine too. So it's kind of in that same world of some concerns over air quality. And basically it's because once the ozone's in the liquid, it's traveling through, that liquid then comes into the float tank, and the ozone starts off-gassing from the water. And how long that takes can vary. I've heard everything from 30 seconds to about 15 minutes. In terms of length of time for ozone to really dissipate out of the liquid. And that's the point where things get a little hairy in terms of air quality. Like basically, you don't want to be breathing in a lot of ozone gas. And there are limits, like OSHA here in the United States has a limit of what they consider a kind of safe work environment, which is they want to see less than 0.1 parts per million of ozone gas in the air, which they're doing over an 8-hour average. But certain other places like the state of Washington in their float tank code has, or the guideline has a limit, just kind of a hard limit of 0.1 parts per million. They just don't want to see it ever go above that number. And those numbers are things, there's also immediate exposure to ozone that could hurt you in higher quantities. So if there's enough ozone gas, you can have immediate health effects. If there's low levels, you can have long-term health effects, typically some sort of respiratory issue that can come up after small amounts of exposure over long periods of time.
And that, to me, is really where the concern lies more. I mean, I guess other than the unit malfunctioning, maybe, and all of a sudden releasing a crazy amount of ozone gas. But if it's operating normally, I guess and then there are different ways to implement this, obviously, both with tools to measure it and make sure ozone doesn't go above certain levels, or machinery to actually evacuate the air and kind of give a good signal when the ozone's done being evacuated. But just sort of, if, for example, you were to build your own float tank and attached an ozonator to it, what I'd be concerned about is that exposure over time, right? Even in a commercial facility, you have your staff are going in to clean the rooms between every person that's in there. Often when they're cleaning the rooms is when the filter is running. So that means that if ozone is getting into kind of the air around the float tank or into the room, you risk having this kind of exposure, which even at low levels for your staff members day in and day out being in there could cause some lung damage.
Yeah, it's one of the kind of interesting things about ozone air quality as compared to the stuff that people bring up about chlorine and bromine is that with chlorine and bromine, that stuff is always being produced, like the disinfectant byproducts that come off of that. So even while someone is in the float tank floating, like, them being in there and stuff that's coming off their body interacting with chlorine can create those disinfection byproducts, or if they're moving around a lot, that can help stuff in the water become gaseous and it'll sit on the water surface, which is right where they're breathing. So there's a lot of kind of concern or kind of a way of understanding how those disinfection byproducts might be very present for customers. But with ozone, one of the interesting things is you're not continuously creating ozone in the duration of someone's float, right? It's kicking on and being created during the filtration process, and then once the filtration process is over, it's kind of degassing in whatever length of time it takes to degas, and then you're not then again continuously pumping ozone in. So it is a concern for your employees and stuff, like Graham said. That's the same time you're in the room cleaning everything. But one of the interesting things is if you can handle that ozone gas, or if you've tracked it so that it's going well, or you have a ventilation system, or you've found a way to solve that kind of part where it's on and it's degassing, then once someone's actually in the system, you don't have that same sort of air quality consideration that you would for chlorine and bromine. So it's a little bit more of a easy to solve problem, or a solvable problem, than chlorine bromine air quality is.
So, I mean, that's kind of the only concern that I have about ozone, is that sort of air quality concern and different things that could lead to that. I
have another concern.
Oh yeah, what is it? What's your other concern?
Just that it's hard to measure. It's unlike some other things, like for a float center to be able to measure the efficacy of their ozonator is not the easiest thing to do on site. It requires a little bit more, either trusting the manufacturer, having some documentation, or testing in the first place to know kind of the scope of how much your ozone is working. So that's the other kind of downside with ozone.
It is kind of like UV in that sense, like these mechanical sort of disinfection machines. Even though you're injecting ozone, it's not like you have this residual chemical that becomes something that you can monitor perhaps a little more simply. Yeah,
it's even a little bit more difficult. I mean, like with UV, you can at least have that like sensor. I mean, maybe there's an ozonator that can have a sensor to show how much ozone it's producing, but I've heard a lot less about that. Often you're either measuring with like a dissolved ozone thing, or you're testing the ozone in the air to extrapolate how much ozone is being injected into the system, or there's a little bit kind of more gaps between what you're measuring and what's being produced in the first place.
Yeah, so I guess making sure that it's working and making sure it's not working too well are almost like the hardest thing.
Hitting that sweet spot.
Yeah.
But other than that, like the nice things about ozone.
Yes, that's what I was going to get to before you interrupted me. But go ahead. You can take the nice things.
It is like, if we're comparing it just to chlorine and bromine, or UV, or hydrogen peroxide, it's really powerful. Like from what I can tell, it's actually the most effective kind of killing agent of each of those things when used on its own. So it's really good at killing stuff.
Yeah, and again, I also think one of the nice things is that if you implement it correctly, it can actually sanitize the walls of the float tank as well, and kind of contribute to kind of an overall cleaner environment, just because it does go into the air and the walls are exposed to it.
And there's this funny kind of push and pull that comes with ozone, where like the benefits and the downsides fight against each other a little bit, which has to do with that. Like one of the nice things about ozone is it has kind of a further reach than UV does. So if you think about UV is only really affecting things when the liquid is moving through that UV chamber that's in your filtration system, as opposed to something like chlorine, which is ubiquitous and just kind of in the liquid everywhere, right? So UV has a little bit more reliance on making sure you're actually doing the right number of turnovers, or you have a reservoir system, or you have some way of really making sure the liquid is properly going through your filtration system, enough times, or with enough kind of mixing that things are being exposed to UV. Ozone is kind of that, like it is being injected in the filtration system, and that's where the most potency is happening, and it's dissipating relatively quickly, but it does go out and mix into the actual float tank and hit some liquid that maybe never made it through the filtration system, or extra exposure, and go up on the walls and things.
And then chlorine, bromine, hydrogen peroxide just sort of chill out there and hang out in the water.
Yeah. But there are ways of mitigating the air quality concerns by trying to stop the ozone from really getting out into the rest of the float tank. So it has the benefit, you have these things called mixing degas vessels, or sometimes those things, like I said, those contact chambers, things like that are devices that attempt to not have too much ozone go back into the thing. The mixing degas vessels are made for pools that have vinyl liners because ozone can damage vinyl. So they built some things to try to stop the ozone from going back into vinyl lined pools and prevent that damage. So the benefit is you can help the air quality issue, and the downside is you're stopping the ozone from getting into the float tank to mix with other stuff or to go up and go on the walls and do any extra cleaning there. So kind of like what helps one thing hurts the other. That's one of the tough parts about figuring out how to best use ozone.
And yeah, random footnote too, but that's initially how chlorine was used as well. We started using it for drinking water purification in kind of the water sanitation world, and it would be introduced into the system in really high quantities and then stripped out afterwards, which is sort of interesting. So it was more of this like inline system rather than something that just pervaded everywhere. Anyway, little chlorine history for you there.
Been reading that Chlorine History book?
I have. It's really interesting stuff. This is what we do for our spare time now. I don't know what's wrong with us. It's become a real problem.
Okay, so
back to ozone, which
the other good thing is that it's also a good oxidizer. So as opposed to just being able to kill things, it's able to kind of eat up organic stuff in there, and which UV is not like the greatest oxidizer, but it is good at killing things. So that doesn't always hold true of something that is good at killing stuff.
So, are there any concerns that you should have about using ozone? Yeah, I mean, definitely. And I think there are actually concerns no matter what form of disinfection you're using for your float tanks. I mean, even just with filtration, making sure that your filters are properly sized and stuff like that. So approaching all of this stuff with caution, no matter what type of system you're using, I think is very prudent. And can those concerns be addressed? Totally. There are, in fact, different ways that you might allay your own concerns and feel comfortable using ozone and not exposing your staff to kind of dangerous levels of it. Or
it's a good conversation to have with a manufacturer if you're looking to buy float tanks and the one you're interested in comes with ozone. Have this conversation. How do I know that the ozone is powerful enough, and how much is coming out, and that part it's effective, and how do I know that there's not an air quality concern or a health risk from exposure to ozone gas from using this system in my float room, which is not going to have an insane amount of ventilation and all this other stuff.
And ask your doctor while you're at it. No, sorry, that's the answer to the previous question, Jan. Anything else on ozone?
Yeah, I mean, other than the fact that all of this stuff is incredibly complicated and nothing is really black and white, and we only know as much as we've gleaned from our years of looking into this. So take this very much as a starting point and not a totality of everything there is to know about ozone.
Yeah, this is not one of the 3 things that we can say with confidence in the world. Cool. Well, thanks for the question. If you have your own,
what should they do?
They should go on down to floattanksolutions.com/podcast. I'm glad you asked.
That's a great suggestion.
And send them in. We love getting them.
Yeah.
We'll send us other stuff too. I mean, we'll take anything.
Anything you want. Yeah.
Pancake sandwich. Yeah.
Okay.
All right, bye everyone.
Bye.